Hi children, how are you all? I hope everyone are safe at home. Right. So today I am going to explain you about matter. What is matter? Anything that occupies space is called as matter, and this matter is mainly categorized into three stable forms, namely solid, liquid and gas. Not only these three states of matter, two more states of matter also exist. They are named as plasma and BEC. Right. Solid, the rigid substances where the interparticular spaces are nil and interparticular forces are high. And coming to the fluids, liquids and gases, the interparticular spaces are high and interparticular forces are low. So depending on the characteristic features of all these particles in the matter is categorized into solids, liquids and gases as well as plasma and BEC. Plasma, the super ionized particles are present, and coming to BEC, Bose Einstein condensate. So initially today we are going to discuss about the solids, liquids and gases interconversion. So by the effect of temperature or pressure, solid can be converted into liquid and liquid can be converted into gas. So you know there are certain processes like namely fusion and vaporization respectively. Fusion is nothing but the melting process where by the effect of temperature pressure the solid is converted to liquid. And coming to vaporization or boiling phenomenon where a liquid state can be converted to gaseous state. So today I am going to explain you the two important processes like fusion as well as vaporization. As you know that we both students and teachers are missing science laboratory. So here this is a wonderful experiment where you can see the fusion process, the melting process. You can also understand what is meant by latent heat of fusion or latent heat of vaporization. But you know that this is a situation where we have to stay at home. So today I'm going to explain you this simple activity which I drew the diagram on the board, and definitely I promise you children that after when you come to the school I'll take you to the laboratory and I'll conduct the experiment. So meanwhile here look at the diagram. Here I have put that diagram on the black into the crushed ice in such a way the bulb is immersed into that crushed ice. The bulb should not be above the crushed ice. It should be immersed in the crushed ice. And here there is a tripod stand, and with the help of Bunsen flame we have to heat that ice, and ice melts, and the melting process of ice into water is called fusion. The process of melting of ice into water is called fusion. So here what you observe here, initially the mercury level raises, and when it comes to 0 degrees centigrade, 0 degrees centigrade is also considered as 273 Kelvin, which is the standard scale for the temperature, measuring temperature. So here the mercury level slowly raises from -20, -15, -10, and finally at 0 degrees centigrade it remains constant. You don't see any raise in the mercury level in the thermometer. Why? The question is, what is happening to the external heat energy that is supplied? Where is it going? Here the answer is like the solid particles. Here I am talking about ice particles. These ice particles are strongly bonded with each other with certain forces, and all these forces ought to be broken. Then only the solid ice is converted into liquid water. So that external heat energy which is supplied from outside is absorbed by these particles, and that energy is hidden among the particles, and this hidden heat energy is called latent heat of fusion. Because here the process of fusion is going on, we name it as latent heat of fusion. So once again I'm telling you the word latent. the meaning of latent is hidden. So even though external heat energy is supplied, we don't see any rise in the mercury level in the thermometer because that heat energy is absorbed or it is hidden among the particles in order to break the forces of attraction. And this is all done during the process. And this mercury level remains constant until the whole ice undergo melting and until the whole ice is converted into water. Slowly, when the whole fusion is done, slowly again the mercury level raises. So this is what we call it as latent heat of fusion. And for every 1 kg of ice, certain heat energy is hidden among the particles. It is around 3.36 into 10 to the power of 5 joules per kg. For 1 kg of ice during the fusion, 3.36 into 10 to the power of 5 joules of energy is hidden among the particles. This is all we have to understand about fusion. And in the same way, if you go with the vaporization, the same process takes place. But here, the water boils at 100 degrees centigrade or 373 Kelvin. Again, the same procedure. When the whole water is undergoing that vaporization or boiling, when water is converted into water vapor, there also again the mercury level remains constant at 100 degrees centigrade. Then the same question is again asked, like where is the external heat energy going? That external heat energy is hidden among water particles in order to break the forces of the water atoms, or let me say the particles in water, and it is used in the conversion, interconversion from liquid state to the gaseous state. And that hidden heat energy which is present in the vaporization phenomenon is called latent heat of vaporization. And it is found that 1 kg of water, let me say 1 kg of steam is hiding around 22.6 into 10 to the power of 5 joules per kg of water. So latent heat of fusion and latent heat of vaporization is the hidden heat energy that is hiding in between the particles during fusion as well as vaporization respectively. So I hope you all understood about latent heat. Once again, I'm telling you, latent is nothing but the hidden heat energy, right? I hope everyone understood this, and in the coming video, I'll be explaining you about sublimation, right?